Hello, all you cool mathematicians and mathletes out there. This video is intended to help review some of the content in your 5th grade week 1 packet. We're going to go ahead and start on page 29, problem number 3. So the problem reads that the owner of a clothing store received a shipment of 1,230 pairs of socks. The socks came in 36 boxes. The same number of pairs of socks were in 35 of the boxes. How many pairs of socks were in the last box? So we are going to go ahead and work this out. So we're going to take 1,230 and we are going to divide it by the 35 boxes we know have an even amount of socks. So we're going to go ahead and do this old school long division style, okay, guys? So if your teachers taught you a different strategy to do long division, by all means, at this point, please do that. We should all still come out with the same exact answer. So 35 goes into 123 3 times, so that's 35 times 3 gives me 105, and when I subtract, I get 18. I'm going to bring on down the 0. 35 goes into 180 5 times, which gives me 175. I subtract, and I have 5 as my remainder. So in this problem, what we have to decide is how we are going to interpret the remainder. So the question wants to know how many pairs of socks were in the last box. Well, we know that in 35 of the boxes, we have exactly 35 sets of socks or pairs of socks. So that means in that very last box, we have 5 pairs of socks. So our answer would be 5. Let's go ahead and move on to the next question, which is on page 30. It is problem number 9. It says, Tommy has 5 jars of marbles. Each jar is 2/3 filled with marbles. If Tommy decides to combine the marbles to completely fill the jars, how many jars of marbles does Tommy have? So, guys, this is real simple multiplication problem. We have 5 times 2/3, all right? And I can put 5 over 1. So now I multiply across, so I have 10/3, or I have 3 1/3 jars. All right, let's move on to our next problem. So Nadia is making a rectangular mosaic out of 1/2 inch by 1/2 inch tiles. The rectangle is 12 inches long, so I'm going to go ahead and put 12 inches on my little area model here, and 3.5 inches wide. All right. It says, how many tiles will Nadia use to cover the rectangle completely? And we know that these little tiny tiles are each 1/2 by 1/2. All right. And we also know that since we're finding the area of this, we know that area equals length times width. So let's go ahead and start by finding the area of the space for our mosaic. So we're going to multiply 12 inches times 3.5 inches. So 12 inches times 3.5 inches is going to mean that this entire area right here is, let's see if I can change this color, is 42 inches squared. All right. And the entire area of our little tiny tile would be 1/2 times 1/2, which would mean that this little thing is 1/4 inches squared. So where do we go from here? A lot of you might have accidentally stopped right there and chosen 42 as an answer, or forgotten the next step. So we still haven't figured out how many of these little tiles are going to go in this entire space. So we have 42 square inches divided by our 1/4 square inches. And so we know that we can't, what we'll do next is we're going to do 42 times the reciprocal, which is 4 over 1. And that's going to equal 168 over 1, or 168 tiles. And I apologize for that sloppy writing, but hopefully you can kind of follow along. There are a lot of problems very similar to this in this week of packets. So you're going to go along with the same kind of idea. All right, let's go ahead and move on to the next question. This question is on page 31, and it is question number 1. It says a tapestry is 5/8 yards long and 3/10 yards high. What is the area in square yards of the tapestry? So again, area equals length times width. So we're going to have our 5/8 times 3/10. So we multiply across and we get 15/80. All right, and let's look at this last question. So a swim instructor has, he's making classes. The swimming instructor can register 12 students in each class and wants to know the least number of classes needed for all students to be registered. We know that there are 152 students. So we are going to divide 152 divided by the 12 students that can be in each class. So we know that, and again, I'm just going to do old school long division. So we know that so we know that 12 can go into 152 12 times evenly, okay? And there's a remainder of 8. Okay, so we have a remainder of 8. The question is, what is the least number of classes needed for all students to be registered in the class? So we have to interpret this remainder. If we only have 12 classes, will all the students actually get to participate? And the answer would be no. That would mean there would be 8 kids that wouldn't get a chance to be in a class. So in order for us to make sure that all 152 of our students get the wonderful opportunity to swim, then we would need 13 classes. Now, I know that was a really quick tutorial of your week 1 packet. If for any chance you have any questions on any other problems or would like to help working them out, you can reach me at muym@leonschools.net. And I know this is kind of a weird time working at home, but remember that you have tons of people who are rooting for you and believe in you, and we're here to help. So keep working hard, mathletes, and I will hopefully see you soon.